Let's take a look at this example. Suppose you have a water-resistant watch that is rated at 5 bar. If you have a watch like this, if you look at the back of the watch, you'll see the 5 bar written on the back of the watch. Okay? What that means is it's able to withstand a pressure of up to 5 bars of water above it, okay, before it would actually break. Okay? So how deep underwater can you go before you would ruin such a watch? Let's try to answer that question. The density of water is a gram per milliliter. So that's 13.6 times less dense than mercury. Okay? So how would you solve this problem? First of all, what you need to realize is this. Okay, so you have your surface of the water right here, right? There's the air above it. There's the pressure from the air, which is equal to the barometric pressure, which is going to be 1 atmosphere approximately. So that's about 1.01325 bar, right? That's the definition of 1 atmosphere, 1.01 bar. So since this is just 1.00, I need 3 sig fig, so it's just going to be 1.01 bar. Right there. Now you're down here with your watch. Okay, here's your watch. There's a column of water above that watch, right? So the pressure of the water column, let's call that P col for column, okay, cannot exceed how much? So this is 1.01 bar, right? This total pressure, when you add those two, the barometric pressure, the pressure due to the column of water, cannot exceed 5 bar. So you want your total pressure to be 5 bar, right? So P total at the depth where you are should be 5 bar. And then further down below that, you'll ruin your watch, right? So that means the pressure due to the water must be what? 3.99 bars. Well, 5 bars minus 1.01, right? So minus the barometric pressure. So you know what this is then. This is going to be equal to 5 minus 1.01. This is 3.99 bar. That's as far down as you can go. So how far down would that be? Well, you can calculate the height then. You can say density of water times G times H must be 3.99 bar, which is times 10 to the 5th Pascal, right? A bar, if you recall, 1 bar is 10 to the 5th Pascal. Okay. Well, what do we know? We know acceleration due to gravity. We know the density of water, so you can solve for that, H. So you just say H equals 3.99 times 10 to the 5th pascals. And we have to put everything in SI units. What's the density of water? 1.00 grams per cubic centimeter, or 1.00 times 10 to the 3rd kilograms per cubic meter. That's the density of water, 1,000 kilograms per cubic meter. Acceleration due to gravity is 9.81 meters per second squared. And so let's calculate that. 3.99 times 10 to the 5th pascals divided by 1 times 10 to the 3rd divided by 9.81, and that gives you 40.7 meters. So this is a height in base SI units, so that's 40.7 meters. So you can go down about 40 meters. How many feet would that approximately? It's about 3 feet in a yard. A yard is like shorter than a meter, so about 120 feet or so. Okay? You go lower than that, you'll ruin your watch. Now, here's another way you could have done this problem. It's a good shortcut when dealing with water. Okay? Since mercury is 13.6 times more dense than water, then you say 1 millimeter of mercury, okay, is going to weigh the same as it's going to have the same pressure as 13.6 millimeters of water. So this is actually a good, you can actually use millimeters of water as a as a unit for pressure. Okay, 1 millimeter of mercury is equivalent to 13.6 millimeters of water. So if you have, if what you do is you can convert your bar into atmosphere, and then you convert it into millimeters of water, millimeters of mercury. So change this to millimeters of mercury, and this is 760 millimeters of mercury, right? So you get your pressure due to water in millimeters of mercury, and then change that to millimeters of water. Okay, so that's one way of, another way of doing this problem. Okay, so you'd say 5 bar, okay, times 1.01, 1 atmosphere, it's 1.01 bar. Okay, so change it to atmosphere, and then change it to millimeters of mercury. 760 millimeters of mercury is 1 atmosphere. Okay, so that gives you how many millimeters of mercury? 3,762.4. Okay, so 5 times 760 divided by 1.01, 3762 millimeters of mercury. That's your 5 bars, right? And then 1 atmosphere is 760, right? That means you cannot exceed, for your water, pressure of your column of water must be 3762 minus 760. That's 3002 millimeters of mercury, right? And so what you can do is you can change that to millimeters of water. You can say 3002 millimeters of mercury times, okay, 1 millimeter of mercury is equivalent to 13.6 millimeters of water. Okay, now you have your height of water, so that's going to be equal to 3002 times 13.6. That gives me 40,827. So that's 40,800, okay, millimeters of water, okay, 3 sig figs, and so that's 40.8 meters of water. So 40.7, 40.8. Okay, so millimeters of mercury, 40.8. I'm sorry, this should be, yeah, millimeters of water. So 40.8 meters of water. Okay, so that's an alternative approach to this problem.